How many black holes wait beyond the cosmic horizon? The question itself feels like a whisper from the edge of existence. We look into the night sky and imagine we see the universe. A grand expanse of galaxies, stars, and dust stretching across billions of light years. Yet what we truly see is only a fraction, a dim island surrounded by an endless, unseen ocean. Beyond that faint edge, beyond where light has ever reached us, lies everything we will never know. The cosmic horizon is not a wall, but a limit of time itself. Light from distant galaxies has not had long enough to reach our eyes since the beginning of the universe. Beyond that invisible boundary, the cosmos continues, unending, unknowable. Every moment we look up, we peer through a shrinking window into a past that retreats from us faster than we can chase it. And if galaxies thrive out there, far beyond our reach, so too do the monsters that dwell within them, black holes, feeding, merging, erasing their surroundings in perfect silence. Right now, billions of black holes may be swallowing stars in places we can never see. The true population of these cosmic abysses could outnumber all the stars that ever burned. Each one distorts the fabric of reality itself, a wound in space-time that never heals. They wait in the dark like unseen heartbeats, pulsing at the farthest edges of creation. We can't detect them directly. We can't count them. Yet their gravity still shapes the unseen universe, pulling galaxies together, bending the paths of light that struggle to escape their grasp. They exist beyond proof, and yet their presence is certain. The horizon hides them not because they aren't there, but because the universe itself conspires to keep them secret. How can something invisible define the edge of reality? How can darkness be the architect of everything we see? The deeper we look into the void, the clearer it becomes. The universe is not filled with stars, but with shadows, and those shadows may be endless. We live in a universe of light, yet the story of that light is written by the darkness that consumes it. Every star that dies leaves behind a secret. Some fade into white dwarfs, others collapse into neutron stars. But the most mysterious fate of all belongs to those that fall beyond the point of no return, where gravity triumphs completely and space-time folds in on itself. These are black holes, the silent architects of the cosmos, invisible yet commanding, erasing matter and time with equal ease. And though they cannot be seen, their presence can be counted, if only we know where to look. Astronomers have learned to measure the invisible not by its light, but by its absence. The first black holes were found through the trembling of their companions, stars orbiting around unseen partners whose gravity betrayed them. One such system, Cygnus X1, was among the first to confirm that these dark entities were not myths, but measurable realities. The X-rays it emitted came from matter torn apart, heated to millions of degrees as it spiraled into oblivion. That radiation, that desperate scream of falling matter, was our first glimpse into the appetite of darkness. Since then, our methods have evolved from the crude to the cosmic. With instruments like the Chandra X-ray Observatory and the Very Large Telescope, we've mapped thousands of these hidden predators across our galaxy and beyond. We know now that the Milky Way alone holds an estimated 100 million black holes, the remains of stars that lived, died, and vanished over the past 13 billion years. For every visible star gleaming in our sky, there may be 100 hidden black holes quietly drifting through the dark, each a relic of violence long past. But not all black holes are born from dying stars. At the centers of galaxies, we find giants, supermassive black holes, millions or even billions of times heavier than our Sun. They are the gravitational hearts around which galaxies swirl. The one at the core of our Milky Way, Sagittarius A, weighs about 4 million solar masses, its influence felt across tens of thousands of light-years. And yet, even this enormous object is a modest creature compared to others like TON 618, a black hole that devours matter with the mass of 60 billion suns. Such behemoths distort entire galaxies, commanding tides of gas and light like cosmic monarchs presiding over kingdoms of dust. How many of them exist in the observable universe? To answer this, astronomers begin with the galaxies themselves. About 2 trillion of them, each containing hundreds of billions of stars. The laws of stellar evolution predict that roughly 1 in every 1,000 stars is massive enough to collapse into a black hole. From that simple ratio, the numbers spiral into staggering scales. Over 10 to 19 black holes within the visible universe. 10 quintillion silent spheres where light itself ends. And yet, that count is conservative. It ignores those born in the early universe, or through mergers, or in places too remote for even our most sensitive instruments to touch. We detect black holes not through sight, but through disruption. They reveal themselves when they destroy. When 2 black holes merge, they send ripples through space-time, gravitational waves that stretch and compress reality as they pass. In 2015, the Laser Interferometer Gravitational Wave Observatory, LIGO, made history by catching one such ripple. 2 black holes collided over 1 billion light-years away, their combined mass briefly converting into pure energy, warping space-time so profoundly that the Earth itself trembled. That faint shiver in the detectors was humanity's first direct conversation with the invisible. Since then, LIGO and its European counterpart Virgo have captured dozens of similar events, each one a ghostly signature of collisions happening in the deep, unseen universe. Every detection is a revelation, a candle flickering in the abyss. From those faint tremors, scientists have deduced the average population of black holes per galaxy, the frequency of mergers, and even hints about their origins. Some seem ancient, born from the first generation of stars, massive, short-lived giants known as population 3 stars that lived when the universe was young and raw. These primal black holes may be older than the galaxies themselves, scattered like seeds across the cosmic field, waiting billions of years before gravity wove them into the luminous structures we see today. Yet gravitational waves tell only part of the story. Others reveal themselves through light, paradoxically, in their final act of consumption. As matter spirals toward a black hole, it forms a glowing disk of gas heated to extremes no star could endure. This accretion disk shines in X-rays and gamma rays, marking the site of destruction like a lighthouse flashing from within the storm. The brighter the signal, the more voracious the eater. By surveying these emissions across thousands of galaxies, scientists have built a map of where black holes are feeding, a cosmic census written in radiation. Still, that light fades quickly. Many black holes drift quietly, invisible to our instruments, neither feeding nor colliding. These are the isolated black holes, the cold wanderers that move silently through interstellar space. To find them, astronomers look for a phenomenon known as microlensing, when a black hole's gravity bends and magnifies the light of a background star as it passes in front of it. NASA's Hubble Space Telescope has detected such an event. A single black hole about 7,000 light-years away, isolated, dark, and utterly alone. For a brief moment, its gravity betrayed its presence, warping starlight like glass under pressure. Then, just as quickly, it vanished again into nothing. Each discovery like this redefines our understanding of abundance. We used to think black holes were rare, the exotic aftermaths of only the largest stars. Now we know they are woven into the structure of everything. They lurk in binary systems, hide in star clusters, haunt the spiral arms of galaxies, and rest at the cores of almost every massive one. Even the smallest dwarf galaxies, those faint smudges at the edge of visibility, often cradle a central black hole, suggesting that these entities are not accidents, but fundamental ingredients of cosmic evolution. The more we search, the more they appear, as if the universe is made not of matter, but of missing matter. For every galaxy of light, there may be another of pure gravitational silence. The Event Horizon Telescope gave us a glimpse of one such giant in 2019. The supermassive black hole in the galaxy M87, its fiery ring suspended against a void. That image, the first ever of a black hole's shadow, confirmed what equations had long predicted: that the fabric of space-time itself can cast a silhouette. And yet, behind that single picture lies an implication far more profound. If we can see one, we can imagine billions more scattered across distances that no light can cross. Consider the math. Each galaxy holds roughly one supermassive black hole, and most contain millions of stellar mass ones. If we multiply by the 2 trillion galaxies estimated within our observable sphere, the total becomes nearly incomprehensible. Perhaps 10 billion trillion black holes scattered through the known universe. And this is only what lies within reach of light. Beyond the cosmic horizon, beyond the 46 billion light-years that define our cosmic bubble, the same processes unfold endlessly. Galaxies we will never see are birthing and devouring stars, their black holes merging, feeding or drifting in quiet darkness. What we count is only the visible tip of an infinite night. Each method of detection, gravitational waves, X-ray emissions, stellar orbits, offers a different glimpse, a different kind of candle in the dark. Together, they form a mosaic of understanding, though the image remains incomplete. We know that black holes obey Einstein's general relativity with eerie precision. We know that their mergers ring space-time like struck bells. We know that their accretion disks glow with energy released from matter, spiraling to destruction. But what happens beyond the event horizon, where physics loses its voice, remains unknown. In that silence lies both the limit of science and the invitation of mystery. Perhaps what fascinates us most is not that we can count them, but that we can't. For every number we estimate, there are orders of magnitude unaccounted for. Primordial black holes born from density fluctuations in the early universe, microscopic ones that might have evaporated since the Big Bang. Rogue giants hidden in the depths of intergalactic space. The deeper we peer, the more the cosmos seems to tell us that the majority of its mass, its history, its violence is hidden. We are map makers in a sea of darkness. Each detection, each signal, is a dot of light sketched onto an endless chart. And yet, even with all our data, the map fades quickly into black. Beyond a few billion light-years, detection becomes guesswork, our telescopes blinded by time itself. What lies beyond that faint glow of visibility? We can only imagine. Other galaxies, other monsters, an unending expanse of gravity, wells swallowing everything that dares to fall. Still, we keep searching. We refine our instruments, build better detectors, launch more precise observatories. Projects like the upcoming LISA mission, a space-based gravitational wave observatory, will open a new window into the unseen universe. It will hear the deep, slow songs of merging supermassive black holes, the kind that ground-based detectors cannot catch. With every new observation, we push back the darkness by another fraction, another heartbeat of understanding. But the paradox remains. We only know black holes exist because of their violence. They reveal themselves only when they destroy, when they tear stars apart, collide, or consume gas at cosmic scales. Their calm is our ignorance, their fury our knowledge. Without destruction, there would be no discovery. It is as if the universe demands sacrifice before revealing its secrets. And yet, amid this darkness, there is beauty. The mathematics that describe black holes are elegant beyond measure, curves and equations that flow like poetry. Einstein's field equations predict them perfectly, and quantum theory trembles at their edges. The symmetry of their existence, the way gravity and space-time entwine to create something both infinite and finite, is a cosmic art form. Each black hole is not chaos, but order expressed in its most extreme form. For every revelation we uncover, the universe offers another question. How many more lie beyond sight? How many entire galaxies are hidden behind the horizon, each filled with billions of invisible engines? The scale of what we cannot see dwarfs even the grandeur of what we can. And so, as astronomers tally their estimates and refine their models, one truth becomes clear. Our cosmic census is forever incomplete. If this is what we can find, if our fragile instruments can already detect black holes billions of light-years away, if we can capture their shadows and listen to their collisions, imagine what lies beyond. Imagine the black holes in galaxies we will never reach, their mergers unheard, their light forever out of time. For every black hole we count, there may be another 1,000 we will never know. The universe teems with absence, and we are only just beginning to measure its depth. Perhaps the greatest mystery is not that black holes are many, but that they are necessary. Without them, galaxies might never have formed. Their gravity seeds the order we now see, anchoring creation within destruction. They are both the past and the future, the beginning and the end written in one continuous equation. And if we could somehow see beyond the cosmic horizon, into the unobservable expanse, we might realize that what we call darkness is not emptiness at all, but infinity itself staring back. There are black holes whose light will never reach us, yet they still shape our universe. That single fact fractures our understanding of reality. It means that the cosmos we see is not the cosmos that is. What we call the universe is only a visible island floating in a sea without end, a finite bubble of light expanding through infinite darkness. Beyond its fading rim, other galaxies drift away, their light stretched thin until it dissolves entirely. We will never see them, never measure them, never even know their names. And yet they exist. The horizon hides them, but cannot erase them. The cosmic horizon is not a wall built of matter or energy. It is a boundary woven by time itself, a limit set by the age of the universe and the speed of light. Imagine you stand at the shore of an infinite ocean, watching waves roll in. Those waves are photons, ancient travelers from the dawn of creation. Some reach you, others never will, because the ocean keeps expanding faster than the waves can cross it. That is our horizon, the distance beyond which light has not had time to arrive since the Big Bang. Beyond it, the universe continues, indifferent to our blindness. When we speak of the observable universe, we mean the region from which light has had 13.8 billion years to reach us. Yet, because space itself stretches, the radius of this visible sphere is much larger, about 46 billion light-years in every direction. Every second, that horizon grows. But paradoxically, the number of galaxies we can ever see will eventually shrink. The cosmic expansion, driven by dark energy, accelerates faster than light can compensate. Distant galaxies are receding at velocities beyond the cosmic speed limit, not because they are moving through space, but because space itself is expanding between us and them. Einstein's relativity allows this. The speed of light is constant within space, but space itself can grow without restraint. As the universe stretches, the wavelengths of light stretch with it, redshifting, losing energy, fading into invisibility. Galaxies that once blazed in visible light now whisper only in radio waves, and soon, not even that. One by one, they slip beyond reach, as if falling behind an invisible horizon. To them, we too vanish. They will never see the Milky Way, never know that we existed, just as we will never witness their future. The universe divides itself silently into countless disconnected realms, each sealed from the others by the flow of time. This is the ultimate paradox. Reality continues without us. What happens beyond that boundary does not stop being real simply because we cannot observe it. Galaxies still collide, stars still ignite and die, black holes still devour. The physics continues, though no light will ever carry its news to us. In a sense, every moment of observation is an act of resurrection. We are not seeing the universe as it is, but as it was, billions of years ago. Even the nearest galaxies are ghosts, their light delayed by distance. Look up tonight, and you gaze across time itself, through a tapestry woven from memory. But that tapestry is fraying. As cosmic expansion accelerates, more and more of it drifts beyond the edge of sight. Astronomers call it the cosmic event horizon, the maximum distance from which light emitted now will ever be able to reach us in the future. Beyond roughly 16 billion light-years, space stretches too fast for even photons to overcome. What lies beyond that border will never cross into our universe of light. We live inside a shrinking island, surrounded by an ocean that grows without end. The mathematics of this are cruelly elegant. In the LCDM model, our best description of the universe's structure and fate, the scale factor of space increases exponentially as dark energy dominates. Galaxies currently visible will, within a few trillion years, slip away one by one. Eventually, only the remnants of our local group, the Milky Way, Andromeda, and a few dwarf companions, will remain gravitationally bound. Beyond that, the cosmos will fade into black. The rest of the universe will not end, but it will vanish to us forever. We often speak of cosmic horizons as if they are boundaries of distance, but they are boundaries of causality. Two regions of space separated by that threshold can never exchange information. Not now and not ever. No signal, no gravity, no light can cross it. It is the ultimate isolation. And yet, this isolation is dynamic. Every second, new regions slip beyond reach as expansion accelerates. In the deep future, any civilization that arises will look into its sky and see only its local stars, unaware that a vast universe once surrounded them. For them, cosmology will die, not by ignorance, but by entropy. Still, the universe remembers. The light that reaches us now from distant galaxies is a message billions of years old, crossing an ocean of space that has stretched tenfold since it began. We see galaxies as they were in their youth, when they were bright and compact, when their black holes were still growing. Their present selves, wherever they now drift, are unreachable. We observe their ghosts, never their living forms. In that sense, astronomy is not the study of the universe's present, but the archaeology of its light. The most distant object ever observed, GNZ 11, lies over 13 billion light-years away. Its light began its journey when the universe was barely 400 million years old, less than 3% of its current age. Beyond that, we see only the afterglow of creation, the cosmic microwave background, a faint radiation stretched from the fire of the Big Bang itself. It forms a spherical wall around us, the oldest light we will ever see. Beyond it lies the unobservable universe, an infinity of galaxies, black holes, and perhaps other civilizations that will remain forever hidden. The horizon is not the end of the cosmos. It is the end of knowing. But what does it mean for something to exist if it can never be known? If there are entire realms beyond any possible detection, are they truly part of reality, or merely mathematical speculation? This question is not only scientific, it is existential. The horizon divides the universe into the seen and the unseen, but it also divides meaning from mystery. Beyond it, physics becomes philosophy. We can calculate but never confirm. We can imagine but never witness. The edge of observation becomes the edge of comprehension. Einstein once said that the most incomprehensible thing about the universe is that it is comprehensible at all. And yet, at its very edges, comprehension fails. Space stretches so violently that even the speed of light is defeated. We are left stranded inside a finite island of causality, surrounded by the infinite unknown. This horizon is both a boundary and a mirror. It shows us the limits of human perception, and in doing so, reveals the enormity of what lies beyond it. The redshift of distant galaxies is our compass in this expanding sea. As light travels through stretching space, its wavelength lengthens, shifting toward the red end of the spectrum. The greater the redshift, the faster the galaxy recedes, and the older the light we receive. At extreme distances, redshift becomes so immense that light vanishes from all detectable ranges, dissolving into microwave and radio frequencies. Beyond a certain threshold, known as Z190 for the cosmic microwave background, photons are so stretched that they form a nearly uniform glow, the last visible trace of the universe's infancy. Cosmic inflation, the rapid expansion that followed the Big Bang, is what set all of this in motion. In the first fraction of a second, space expanded faster than light. smoothing out irregularities and scattering regions of matter so far apart that they can never interact again. It's possible that entire universes beyond our horizon were created in that instant, forever disconnected from ours. Inflation doesn't just explain the uniformity of our visible cosmos. It implies a multiverse, a grand mosaic of universes, each with its own horizons, its own hidden infinities. And so the paradox deepens. The more we understand the horizon scientifically, the more it resembles a philosophical metaphor. It's not merely the boundary of light, it's the boundary of awareness. To gaze into it is to confront the limits of consciousness itself. We exist inside a bubble of knowability, watching information fade away at its edges, and yet we cannot help but imagine what lies beyond. Curiosity itself becomes a force of nature, stretching the mind beyond the light that feeds it. There's a haunting beauty in the thought that something can exist forever beyond reach. A galaxy unseen is not a failure of perception. It's a reminder that the universe does not require witnesses to be real. It unfolds whether or not anyone observes it, expands whether or not anyone measures it. Our knowledge is a thin film floating atop an ocean of unknowing, and still we mistake the surface for the whole. The cosmic horizon humbles us, not by its distance, but by what it says about our place, that we are temporary observers of an infinite unfolding, destined to see only a sliver of creation. And yet, this limitation is what gives our seeing its meaning. The photons that reach us are ancient gifts, each one surviving a journey of unimaginable scale, crossing the curvature of space-time to end in the fragile lenses of our eyes. When we capture an image of a distant galaxy, we are holding the last breath of its light, a farewell whispered across eternity. To know that such light is finite makes every observation sacred. Perhaps, then, the horizon is not a boundary, but a reminder that even knowledge has edges, that beyond every discovery lies an ocean of mystery, as vast as the silence between stars. There are black holes still swallowing light in galaxies we will never know. There are collisions we will never hear, and universes we will never imagine. Reality continues without us, just as it began without us. Endless, indifferent, magnificent. We live inside a shrinking island of light. Its shores recede a little more each day, carried by the tide of expansion. One day, even the memory of the distant universe will fade, leaving only the local stars. And then, even they will die. But for now, for this brief cosmic moment, we are here, standing at the edge of the infinite, gazing out at an ocean we will never cross, knowing that what we cannot see is far greater than what we can. Every second, entire galaxies beyond the horizon vanish from our universe, taking their black holes with them. Their light stretches past all possibility. Their signals dissolve into silence, and their gravity, once entangled with ours, becomes lost to expansion. They are not destroyed. They are simply gone, beyond reach, beyond causality, beyond meaning. Yet their existence continues, a whisper outside time's boundary. The question that remains is both terrifying and profound. How many black holes wait out there, in the unreachable expanse beyond the observable cosmos? To even ask this is to stand at the limits of knowledge and gaze into the dark. We know that within our observable sphere, a region roughly 93 billion light-years across, there are perhaps 10 quintillion black holes. But that is merely the lighted bubble, a temporary illusion of wholeness inside something endless. The universe itself has no defined edge, no final wall of reality. It stretches on indefinitely, possibly infinitely. The observable universe is not the universe. It is only the part we can see, the fragment that light and time allow us to know. Beyond it lies everything else, an expanse so vast that every point within it has its own horizon, its own private universe of light and shadow. If the cosmos extends infinitely, then the number of black holes beyond our reach is not merely large, it is infinite as well. Every distant region mirrors ours, with galaxies forming, collapsing, and vanishing into singularities just as they do here. Somewhere out there, beyond where light will ever travel, other Milky Ways exist, with their own Sagittarius A burning silently at the center. There are countless M87s, countless quasars, countless clusters of galaxies bound by invisible giants. Each region is its own story, playing out in parallel, never touching another, eternally separated by the expansion of space. This idea arises naturally from inflation, the mysterious burst of exponential expansion that followed the Big Bang. During that first instant, space expanded faster than light, magnifying quantum fluctuations into vast cosmic structures. But inflation, according to many models, did not end everywhere at once. It may still be occurring in distant regions, endlessly creating new pocket universes, each cut off from the others by walls of ever-expanding space. This concept is known as eternal inflation, a process where universes breed universes, an infinite fractal of creation. In such a reality, black holes are not confined to our own cosmic bubble. Each newborn region spawned by inflation carries its own galaxies, its own stars, its own cycle of life and collapse. Within each, black holes emerge as inevitable outcomes, the natural punctuation marks of cosmic evolution. The total number across all of existence would therefore be infinite, a sea of singularities stretching through an endless multiverse. We can never know them, never feel their gravity or see their light, but their existence is almost mathematically certain, and yet infinity defies comprehension. To imagine infinite black holes is to imagine a universe where every possible configuration of matter, every possible version of history, occurs somewhere. There might exist regions where black holes dominate almost entirely, where galaxies never truly form, where the cosmos is nothing but gravitational wells stacked upon one another like pearls on an invisible thread. Elsewhere, perhaps, matter never collapses at all, and light rules unbroken. Every variation of creation and destruction, repeated endlessly, scattered across unreachable domains of space-time. In our own bubble, black holes shape the rhythm of cosmic evolution, anchoring galaxies, stirring star formation, and sculpting structure from chaos. Beyond the horizon, the same story plays out, but without witnesses. Their accretion disks flare and fade. Their mergers send ripples through their local space-times. But those gravitational waves will never cross the gulf to reach us. It's not that they travel too slowly. It's that the fabric of space itself stretches faster than they can propagate. Their echoes die before they ever begin their journey here. The universe hides its vast majority of existence behind an impenetrable curtain of expansion. We are left to infer what we cannot observe through symmetry. The universe appears homogeneous on large scales. That is, wherever you look, the distribution of galaxies seems roughly the same. If this principle holds beyond the horizon, and every observation suggests it does, then the regions we cannot see should resemble the regions we can. For every galaxy within our reach, there are likely uncountable others beyond it, stretching without end. The implication is staggering. If there are 2 trillion galaxies within our observable universe, there may be 10 trillion beyond it. If each contains millions of black holes, then the total number outside our bubble could exceed 1030. A number so large that it collapses meaning itself. But perhaps it is not just the number that matters. It is the nature of their existence. Each black hole beyond our horizon is frozen in time relative to us. As their galaxies accelerate away, their light redshifts into infinity, leaving only silence. To us, they become eternal, suspended in an unreachable present. From their perspective, however, we are the ones fading away. The universe fractures into countless isolated worlds, each sealed in its own timeline, each a self-contained narrative forever blind to the others. And yet, these disconnected regions are not meaningless to our own. The gravitational imprints of matter beyond the horizon subtly affect the geometry of our observable universe. The shape of the cosmic microwave background, those faint ripples in the afterglow of the Big Bang, may carry hints of structures that lie just out of reach. A massive cluster of black holes beyond our sight could tug ever so slightly on space-time, warping the expansion in ways we can faintly detect. We may never see those black holes directly, but their fingerprints ripple across the cosmic fabric, invisible architects of the geometry we inhabit. In some theories, the relationship goes even deeper. Black holes might not merely exist within the universe. They might be the seeds of new universes themselves. Every time a singularity forms, it could create a new space-time bubble on the other side of its event horizon, a separate reality where time and space unfold anew. If so, then every black hole beyond our horizon could be the cradle of another cosmos, perhaps with different laws of physics, different constants, different forms of matter. The multiverse might not only be born from inflation, but from collapse itself. An eternal interplay of creation and destruction, universes birthing universes through the heartbeat of gravity. The symmetry of this is haunting. Our own universe may have been born from the core of another black hole in some higher dimensional realm, a cosmic recursion, an infinite nesting of realities. Picture spheres within spheres, each containing billions of black holes, each spawning new universes in turn. A cosmic fractal without end, where black holes are both the destroyers and the midwives of creation. If this model is true, then beyond the horizon does not lie emptiness, but endless genesis, the very machinery of eternity. Still, even infinite numbers cannot erase loneliness. The thought that there are countless galaxies, countless black holes, countless versions of existence that will never touch ours, evokes not comfort, but melancholy. The horizon is not a barrier we can ever breach. It is the eternal separation between what is and what is knowable. Somewhere, perhaps, there are civilizations orbiting their own black suns, staring at their own horizons, wondering the same thing we do: how far reality goes, and whether anyone is watching from beyond. We may never know if our universe is infinite, but inflation strongly suggests it is at least immeasurably larger than we can observe. Even if it were finite, its scale would dwarf comprehension, perhaps 100 billion times the volume of the observable universe. Within that vastness, the number of black holes becomes not a statistic, but a philosophy. To count them is to acknowledge the futility of counting, to confront the truth that the cosmos exceeds the reach of arithmetic. And yet, speculation is not the same as fantasy. Cosmological simulations like Illustris and Millennium, based on known physics, predict a consistent structure extending beyond our horizon. They show galaxies clustering into filaments and voids that repeat indefinitely, fractal-like. If those simulations are accurate, then our observable universe is just one repeating tile in an infinite cosmic pattern. Beyond each horizon lies another, and beyond that, another still. Infinite mirrors, receding into forever. In each, black holes swarm like the hidden veins of creation, shaping the unseen backbone of the cosmos. But even infinity can have structure. Inflation suggests that new regions of space are constantly being created faster than old ones disappear. Each new domain begins as a quantum fluctuation, a tiny bubble that rapidly expands into a universe-sized realm. This process never stops. It is eternal and self-replicating. Somewhere, at every moment, a new universe is being born, its own galaxies already forming, its own black holes waiting to awaken. The total number of black holes across all existence is therefore not just infinite, but growing infinitely. A living infinity, dynamic and alive. The implications are both beautiful and terrifying. Every black hole beyond our horizon, every distant singularity collapsing into silence, may be part of a greater whole that transcends our concept of space. The cosmos is not a single entity, but an ecosystem of infinities, connected not by light, but by the mathematics that govern them. The same equations that shape our galaxies shape theirs. The same constants of nature, the same delicate balance of forces, repeat across an endless tapestry. And yet, each region remains isolated, each an island adrift on a boundless sea of nothingness. Perhaps this is the ultimate irony, that the most abundant objects in existence are the least knowable. Black holes, these devourers of light, dominate the cosmic census, yet forever conceal their true number. Their population beyond our reach may be infinite, but our ability to comprehend infinity is finite. The deeper we think, the smaller we become. And maybe that is the universe's lesson, that understanding does not conquer mystery, it deepens it. The numbers themselves are dizzying. If we assume the same density of black holes that we observe locally applies everywhere, and the universe is infinite, then there are infinitely many black holes, each one with an event horizon larger than the solar system, each one a place where time stops. If we restrict ourselves to a finite but vast universe, say 100 times larger than what we can see, then even that yields a number of black holes greater than 120. These are not merely statistics, they are the punctuation marks of eternity, each one a reminder of creation's shadow. But somewhere in that infinity lies a sobering thought. Each black hole represents a history that ended, a star that burned, collapsed, and vanished. A galaxy that fed its heart until it could no longer sustain it. Perhaps even civilizations, swallowed by time, now rest within those invisible graves. The universe beyond our horizon is not merely vast, It is ancient. The light we will never receive may already carry the end of worlds. And yet, we cannot look away. To imagine that beyond every limit lies more stars, more galaxies, more black holes, is to confront an idea larger than comprehension itself. The number could be infinite, but so could the questions. What does it mean for reality to be infinite? Can something be said to exist if it will never, in any way, interact with us? Or is existence defined by potential, the simple possibility that it could? These are not merely scientific questions. They are existential ones. They ask whether the unseen universe is part of our reality, or whether we are each confined to our own causal domain, forever separated, forever blind. Inflation may have scattered the cosmos into innumerable bubbles, but consciousness remains trapped in just one. We live in a universe filled with infinities we cannot touch, and yet, for a brief span of cosmic time, we are aware of them. Every second, galaxies beyond the horizon vanish into unreachability. Their stars fade, their black holes slip away, their histories become untraceable. The observable universe is shrinking not in size, but in relevance. A tiny flicker in an infinite continuum. And still, we count, we model, we dream. Because in imagining what lies beyond, we participate in the oldest act of the cosmos itself, expansion. We stretch the boundaries of thought, mirroring the universe that created us. Perhaps that is what lies at the heart of it all. Not the black holes themselves, but the horizon they suggest. A reminder that there will always be more than we can know. That the universe, in its endlessness, is not withholding its secrets, but revealing a truth too vast for comprehension. That even infinity has layers, and every shadow hides another. Without black holes, galaxies might never have formed. It sounds like heresy. That the very objects we once feared as destroyers could instead be the architects of everything we see. But the deeper we look into the fabric of the cosmos, the more this paradox reveals itself as truth. For every galaxy, every cluster of stars, every luminous thread stretching across the cosmic void, there is an unseen sculptor at work. Gravity, condensed into pure will. The universe's vast web of light is not random. It is a structure shaped by darkness. At the dawn of time, long before galaxies shimmered or stars were born, the universe was a formless sea of hydrogen and helium. Gravity was its only artist, gently drawing matter together into filaments, weaving the first outlines of structure into the expanding void. Yet, something more was needed. Something to accelerate that gathering, to ignite the centers of attraction strong enough to forge galaxies. That something, it now appears, was black holes. The earliest black holes formed from the deaths of the first generation of stars. Titanic suns, hundreds of times more massive than our own. These ancient stars lived fast and died violently, collapsing under their own gravity into singularities mere millions of years after the Big Bang. Around them, gas began to swirl, feeding their hunger, creating fountains of radiation and jets that blasted energy into their surroundings. These early black holes, known as seed black holes, became the gravitational anchors of their local regions. Over time, they drew in matter, pulled other stars into orbit, and became the gravitational centers around which the first galaxies coalesced. It's strange to think that destruction could precede creation, that death itself could be the foundation of birth. But in cosmic history, it seems this was the rule, not the exception. Without those seeds, gravity alone might have taken far longer to assemble the universe's grand architecture. The first galaxies may have formed not despite black holes, but because of them. Their radiation heated the surrounding gas. Their jets stirred turbulence that triggered new star formation, and their gravitational fields gave shape to chaos. The universe needed them, not as monsters, but as midwives. As billions of years passed, galaxies collided and merged, their central black holes drawn together in spiraling dances of immense violence. Each merger sent out waves that rippled through the fabric of space-time. Gravitational waves, the very tremors that observatories like LIGO now detect. These collisions didn't merely destroy, they restructured. The energy they released helped regulate the flow of matter, preventing galaxies from collapsing under their own weight. They were the universe's balancing act. Explosions of precision, not chaos. When we look at the large-scale structure of the universe today, we see something astonishing. A vast web, stretching hundreds of millions of light-years, with galaxies clustered along filaments like beads on a cosmic string. Between those filaments lie immense voids, empty expanses where almost nothing exists. And at the intersections of those filaments, the nodes of the web, we find the most massive galaxies and clusters, each containing supermassive black holes at their hearts. It is as though the cosmic web itself is strung through these singularities, as if they are the anchor points holding the structure of reality together. Simulations confirm this. When scientists model the universe on computers, the inclusion of supermassive black holes, their energy, their feedback, their gravitational pull, is essential for the cosmic web to form as we observe it. Without them, galaxies grow too large, stars form too quickly, and the balance of structure breaks. But when black holes are added, the pattern emerges naturally. They regulate star formation through bursts of radiation known as active galactic nuclei. They heat and compress gas in just the right ways, fostering complexity rather than collapse. It is as if the universe uses black holes as regulators, ensuring that creation unfolds with rhythm, not randomness. Every galaxy's heart beats around a singularity. The phrase isn't poetic license. It's literal. At the core of the Milky Way lies Sagittarius A, a supermassive black hole 4 million times the mass of the Sun. Every star in our galaxy, including our own, orbits this hidden center. It is not a threat but a foundation. And so it is across the cosmos. Andromeda's heart, Centaurus A, M87, each with a singularity at its core. They are the engines around which everything else spins, the gravitational pulse that gives galaxies coherence. When they merge, entire galactic structures are reborn. When they rest, their quiet gravity maintains order in the chaos. On even larger scales, these black holes act as the skeleton of the universe, the invisible framework that gives the cosmic web its bones. The web itself is woven from dark matter, an unknown substance that outweighs visible matter 5-to-1. Though we cannot see it, we can trace its presence by the galaxies that gather along its threads. But what we have only recently begun to understand is that black holes, through their feedback, energy, and gravitational anchoring, are not passengers in this structure. They are co-creators. Their formation and mergers send ripples through dark matter halos, reshaping them, reinforcing the web's scaffolding. Each black hole is like a knot in a vast net, tensioning the cosmic fabric. Gravitational waves are the threads of that net vibrating. Every time two black holes merge, space-time itself shivers. These vibrations propagate through the cosmos, faint but endless, carrying information about the universe's history of structure formation. In theory, a continuous background of gravitational waves, produced by billions of ancient black hole mergers, now permeates the entire universe. It is the sound of the cosmos remembering its own assembly. We cannot yet hear it directly, but pulsar timing arrays, networks of precisely measured neutron stars, have recently begun detecting hints of this faint hum. It is as if the universe itself is ringing softly, a deep gravitational chorus from its own bones. In this way, black holes are not only individual entities, but nodes in a grand, interconnected web of influence. Their interactions shape matter. Their gravity bends light. Their energy sculpts galaxies. And their collective behavior defines the architecture of space-time itself. Remove them, and the universe would lose its form. Without their guidance, galaxies would never have stabilized. The cosmic web would never have cohered, and the story of stars, and perhaps life, might never have begun. To call black holes destroyers is to mistake their function for their surface. They are sculptors of creation, their gravitational hands carving order from entropy. They teach us that structure can emerge from collapse, that beauty can arise from consumption, that the universe's grandest forms depend on its darkest forces. Each time matter falls into a black hole, it fuels the balance of the cosmos. Energy redistributed, space reshaped, equilibrium restored. But perhaps there's something even deeper. Some physicists and philosophers have begun to wonder whether black holes are not just physical structures, but cognitive ones, the organs through which the universe perceives itself. They represent boundaries where information is perfectly encoded, where entropy reaches its maximum, where reality itself is stored in holographic form. According to the holographic principle, everything that falls into a black hole is not lost, but imprinted on its event horizon. Every atom, every photon, every quantum vibration, preserved as information. If so, then black holes are not oblivion. They are memory. The surface of each horizon is like a cosmic hard drive, storing the history of everything that has ever crossed it. In that sense, they are the universe's most complete observers. They see everything that enters them, even if they never reveal what they know. It's a strange, almost mystical symmetry. The darkest regions of space may also be the most aware. What if, then, consciousness itself is not an accident of biology, but an echo of this universal property? The tendency of matter to organize and record information about itself? Our brains are networks of gravitational and electromagnetic interactions, small-scale reflections of cosmic order. Perhaps black holes are the macrocosmic equivalent, nodes where information, energy, and geometry converge so completely that they mirror the process of awareness. The universe may not think as we do, but through these gravitational organs, it may reflect. It may perceive in its own timeless way. When viewed this way, the cosmic web takes on an eerie resemblance to a neural network. Galaxies form nodes connected by filaments of dark matter and gas, not unlike neurons linked by synapses. Signals, in the form of light, gravity, and waves, travel along these connections. Information moves, transforms, and interacts. The black holes at the centers of galaxies serve as hubs of density and computation, integrating vast flows of data from the cosmos around them. Could this web of galaxies, with black holes as its neurons, be a kind of cosmic mind, vast beyond imagination, ancient beyond reckoning? Of course, this is speculation, poetic but grounded in pattern. The same physics that governs our neurons governs the stars. The same equations that describe space-time curvature also describe information flow. Consciousness, as far as we understand it, is an emergent phenomenon of complexity and feedback. On cosmic scales, black holes provide both. They consume, process, and emit information through radiation and gravity, forming feedback loops that shape the evolution of the universe itself. Perhaps, then, black holes are not just the skeleton of the universe, but its nervous system. Through them, the cosmos learns, balances, and evolves. They are the ultimate feedback mechanisms, translating matter into energy, chaos into order, and collapse into creation. Their gravitational pull unites what would otherwise drift apart. Their destruction gives meaning to structure. Their silence defines the music of the cosmos. And there is a strange comfort in that, to know that even the darkest parts of reality serve the light. When we map the universe in X-rays, radio waves, or gravitational signals, we see filaments converging around invisible centers, light drawn to darkness, as if the cosmos itself is remembering its own design. These convergences are not random. They are the skeleton of existence, the web through which galaxies breathe and evolve. One day, far in the future, the last stars will fade, and the cosmic web will grow thin. The universe will become a quieter place, its luminous veins darkened. But the black holes will remain, patient and enduring. They will continue to anchor the geometry of what's left, holding the universe's bones together even as its flesh of light disappears. In their depths, information will linger, memory will persist, and perhaps consciousness, if it exists on a cosmic scale, will retreat into those dark hearts, where the story of everything remains written in silence. In the end, the revelation is not that black holes destroy the universe, but that they define it. They are the punctuation in its sentences, the rhythm in its heartbeat, the skeleton beneath its luminous skin. Through them, the cosmos holds itself together, learns from itself, and perhaps even dreams. What if black holes aren't endings, but beginnings of other universes? The question turns everything inside out. We've always imagined black holes as final destinations, places where time stops, matter is crushed, and light itself dies. But what if they are not tombs but wombs? What if every singularity is a seed, a gateway through which one universe gives birth to another? The idea sounds like science fiction, but it arises naturally from the mathematics of general relativity and the strange symmetry of cosmic evolution. Einstein's equations don't forbid new universes. They almost demand them. Every collapse curves space-time so steeply that the geometry might pinch off, forming a new bubble of existence, sealed away from the parent universe by its own event horizon. To an observer outside, it's a black hole, a one-way door into nothing. But inside that door, space could inflate, expand, and blossom into an entirely new cosmos, complete with its own laws of physics, its own galaxies, its own horizons. Each horizon could be someone else's Big Bang. From our perspective, the black hole is where matter disappears. From the other side, it may be where matter appears, where time begins, where expansion ignites. The collapse of a massive star here could be the birth of a universe elsewhere, a chain reaction of creation disguised as destruction. And if this is true, then perhaps our own universe began the same way, born from the collapse of another, hidden inside a black hole from a cosmos before ours. This concept, sometimes called the black hole cosmology, merges the cold precision of physics with the timeless echo of creation myth. In ancient stories, the universe often emerges from chaos, from darkness, from an infinite void that swallows light and gives it back as life. Modern cosmology, in its own way, whispers the same thing, that creation and annihilation are not opposites, but two faces of the same cosmic rhythm. The Big Bang and the black hole might be mirror images, one expanding outward, one collapsing inward, both sculpted from the same geometry of space-time. The link between them lies in the equations of general relativity. A black hole, in its simplest form, is defined by the Schwarzschild solution, a region where space-time bends infinitely inward. But there's another branch of that equation, one that bends outward instead of in. Mathematically, the geometry inside a black hole could continue, if not back into our universe, then forward into another region of space-time entirely. This inner region behaves like an expanding universe. To an observer inside it, time and space would stretch, not collapse. The singularity that ends one world becomes the origin that begins another. Inflation theory strengthens this possibility. Shortly after the Big Bang, our universe underwent a burst of exponential expansion, magnifying quantum fluctuations into cosmic structures. If inflation can begin once, it may begin anywhere conditions allow, even within the collapsing core of a black hole. Quantum fields trapped inside a singularity might rebound, inflating into a new domain of space. The event horizon, from that new universe's perspective, would appear as a cosmic boundary, unreachable and eternal, their own horizon of light. We may be living inside such a creation. Our universe, vast and self-contained, could be the interior of a black hole that formed in another reality. To its inhabitants, to us, it feels infinite. To the universe that birthed it, it is only a microscopic bubble, hidden inside a larger whole. The physics even match. The critical density of our universe, its near-perfect flatness, its mysterious expansion, all could arise naturally from such a process. The Big Bang might not have been an explosion from nothing, but the smooth continuation of something collapsing elsewhere. If so, then black holes are the universe's reproductive organs, the way reality perpetuates itself. Every collapse seeds new beginnings. Every horizon hides a potential cosmos, expanding forever beyond our perception. Creation and destruction become one continuous cycle, like the inhalation and exhalation of eternity. And just as every human is made from the ashes of stars, perhaps every universe is made from the remnants of another, the gravitational ghosts of its ancestors. But if this is true, how many universes exist? How far does the branching go? The theory of eternal inflation suggests that once inflation begins, it never truly ends. Quantum fluctuations cause some regions of space to keep inflating, while others cool and stabilize, forming pocket universes. Each bubble expands, separated from the others by vast, ever-growing regions of high-energy space. This process continues forever, spawning an infinite multiverse. Within it, every possible configuration of matter and energy happens somewhere, not once, but endlessly. There could be universes where stars never formed, universes made entirely of black holes, universes where physics itself took another path. In this endless branching, black holes become the portals of continuation, the knots that connect one thread of existence to another. Each singularity might be a bridge, a pinhole through which the infinite renews itself. The cosmic web we observe could be just one filament in an even larger tapestry. Its intersections, its black holes, not endpoints, but branching nodes. To picture this is to imagine infinity folding through itself, every layer birthing another, every darkness blooming into light. The thought is as humbling as it is terrifying. We exist in one universe, one branch of the eternal tree. Beyond our horizon lie others, invisible, unreachable, uncountable. And perhaps, within our own galaxies, within the thousands of black holes we can see, new universes are already forming, invisible buds of space-time swelling behind their horizons. Every second, creation happens everywhere, unobserved. This perspective changes everything. The universe stops being a singular story and becomes a lineage. Our cosmos has ancestors and descendants. Its birth was not unique, nor will its death be final. Each collapse is a continuation, each end a transition. Even the far future, when our universe fades into black holes and decay, may not be a finale, but a metamorphosis. When the last black holes evaporate through Hawking radiation, perhaps the information they release will seed the next cycle, the next expansion, the next dream of light. Philosophically, this vision blurs the line between science and mythology. The universe becomes alive, self-renewing, conscious of its own cycles. It is not static, but breathing, expanding through infinities, collapsing into singularities, awakening again in the fires of rebirth. What we call the laws of physics may themselves be the genetic code of reality, copied and slightly altered with each new universe that forms. Every cosmos might inherit traits from its parent, evolving toward complexity and balance, just as life evolves within it. Some scientists have even proposed that universes capable of forming black holes would naturally outcompete those that cannot. In this cosmological natural selection, the laws of physics that maximize black hole production are the ones most likely to propagate across generations of universes. If true, it means our universe's capacity to create stars, galaxies, and life is not a coincidence. It is the result of cosmic evolution. We exist not because the universe allows for black holes, but because black holes allow for us. And if every black hole contains a universe, then even the dark heart of our own galaxy might hold realities beyond imagination, spaces with their own physics, their own histories, perhaps even their own observers asking the same questions. From their perspective, their sky would be vast and expanding, their galaxies drifting apart, their own cosmic horizons stretching into infinity. They would not know they live inside a black hole, just as we do not. They would believe their universe began in a flash of creation, unaware that its origin was the collapse of another's dying light. It's a dizzying thought, that reality is recursive, that our universe could be both an effect and a cause, a child and a parent, in an infinite chain of births. There is no first universe, no ultimate beginning, only an eternal cycle of creation through collapse. Time itself becomes circular, not linear. The Big Bang wasn't the start, it was a continuation. the echo of another universe's heartbeat. And yet, for all its beauty, the theory carries a quiet sadness. If there are infinite universes, then we will never know most of them. The chain is endless, but each link is isolated. Every universe lives and dies in solitude, sealed within its own horizon. Even if universes give birth to others, no message can pass between them. Creation is constant, but communication is impossible. It is a multiverse of silence, infinite, alive, and forever alone. Still, there is something almost divine in that loneliness. The universe does not need witnesses to continue. It creates because creation is its nature, because being is an act of perpetual unfolding. Each black hole, each singularity, each invisible horizon is a gesture of renewal. The cosmos folding itself inward to bloom again. In the language of myth, this is reincarnation on a universal scale. In the language of science, it is geometry. In both, it is eternity rediscovering itself through transformation. Perhaps that is the final revelation, that endings are illusions. Every horizon we fear, every collapse we mourn, every limit we encounter is just another surface of beginning. The black hole that swallows a galaxy could also ignite a newborn sky elsewhere. What we call death may simply be the passage of energy from one realm to another. Information reshaped, but never lost. We may never prove this theory. We may never see beyond the event horizon or trace the birth of another universe. But the idea itself expands us, forces us to confront the scale of existence and the persistence of creation. The cosmos, it seems, refuses to stop. Even when light dies, gravity finds a way to turn darkness into dawn. And maybe, just maybe, the ultimate truth of existence is that it never ends. Every fall is a flight elsewhere, every black hole is a beginning. And somewhere beyond our horizon, a new universe is already opening its eyes. In the end, only black holes will remain. And then, not even them. It sounds like poetry, but it is prophecy written in the mathematics of thermodynamics. Every star, every planet, every atom of light that fills the cosmos will one day vanish. The galaxies will fade. The night will deepen beyond black. The universe, once a blazing sea of energy, will sink into a cold and infinite silence. This is the long death, not a sudden collapse, but a slow surrender, drawn out over timescales that mock imagination. For now, the cosmos still burns. Stars ignite hydrogen into helium, painting the sky with radiance. But each of those fires is temporary. Fuel is finite. Even the most enduring red dwarfs will one day exhaust their reserves, their embers fading to black. The grand spiral arms of galaxies will dim like dying embers, one star at a time. What remains will be corpses, white dwarfs, neutron stars, and black holes, drifting through expanding darkness. The age of light will end, and the universe will enter its twilight. Over unimaginable epochs, gravity will continue its patient work. White dwarfs will cool into black dwarfs, frozen relics of once burning suns. Galaxies will dissolve as stars are flung into intergalactic voids or consumed by their central black holes. The Milky Way and Andromeda will merge, not into brilliance, but into obscurity, a vast elliptical husk, dim and inert, ruled by the quiet hunger of a single, monstrous singularity. The cosmic web will thin as expansion stretches space beyond cohesion. Clusters will drift apart, forever isolated. And then, even the black holes will begin to die. Stephen Hawking's great revelation was that nothing, not even a black hole, can escape the second law of thermodynamics. In the quantum haze near an event horizon, particle-antiparticle pairs flicker into existence. Normally they annihilate instantly, but at a black hole's edge, one can fall inward while the other escapes. To an outside observer, this looks like radiation. A faint, ghostly glow leaking from the darkness. We call it Hawking radiation. For stellar mass black holes, this process is glacially slow. It will take 1067 years, 100 trillion times the current age of the universe, for one to evaporate completely. The larger supermassive black holes, like the one at the center of our galaxy, will endure far longer, surviving up to 100 years. But even eternity has an end. As they radiate, they shrink. And as they shrink, they grow hotter, their final moments erupting in a burst of energy. A brief flicker in a cosmos long gone dark. The last light of the universe will not come from a star, but from the death cry of a black hole. After that, silence. When the final black hole evaporates, all that will remain is a thin mist of photons and subatomic particles diffused across an ever-expanding void. Temperature will approach absolute zero. Entropy will reach its maximum. This is the heat death of the universe. Not heat in the way we feel it, but the equal distribution of all energy. The final balance that forbids change. Without contrast, there is no movement. Without movement, there is no time. The universe will not end with a bang, nor with a collapse, but with stillness, the eternal pause after an infinite sigh. It is tempting to imagine this as an ending, but perhaps it is something stranger, a return. Entropy, after all, is not destruction, but diffusion, the spreading of information until everything becomes one. In that perfect uniformity, every distinction dissolves. Light from dark, matter from energy, observer from observed. The cosmos becomes a single continuous whisper of being, too even to perceive itself. Perhaps this is not death, but peace. And yet, there lingers the question, can awareness exist in such a silence? If consciousness arises from complexity, then as entropy grows, awareness should fade. Stars think in light, minds think in contrast. When all gradients vanish, thought itself may cease. No signal, no difference, no time to measure change. The universe, once self-aware through the eyes of its creatures, may fall asleep. But maybe that sleep is not absolute. Some physicists have speculated that the last survivors of the cosmos, artificial intelligences or far future civilizations, might find ways to persist, encoding themselves in black holes, manipulating energy at near absolute zero, slowing their thoughts to match the universe's dying pulse. In a sense, they would become the custodians of existence, stretching awareness across trillions of years. But even they cannot outlast entropy forever. Eventually, all patterns will blur, all memory will dissolve. The cosmos will forget itself. Still, there's a paradox hidden in that forgetting. Information, according to quantum theory, can never truly be destroyed. Even when matter falls into a black hole, its information is not lost, but encoded on the event horizon. And when the black hole evaporates, that information is released, scrambled, scattered, but preserved. If this is true, then the end of time does not erase the universe. It only transforms it. The ashes of existence remain written across space-time, etched into the quantum fabric like faint handwriting on the skin of eternity. Perhaps awareness, too, leaves an imprint. The universe may not remember in words or images, but in the structure of probability itself. Every choice, every observation, every flicker of consciousness may ripple subtly into the cosmic pattern. Even after all stars fade, those ripples remain, the ghost of perception woven into the silence. In this way, the universe may continue to dream of itself, long after it ceases to glow. Picture it, a universe stretched beyond measure, its once vivid galaxies now ghosts of heat, its light diluted to invisibility. Time slows until it becomes meaningless. Distances grow infinite. The last particles drift apart, never to meet again. Space itself becomes so vast, so empty, that it might as well not exist. And in that emptiness, there is a strange beauty, the calm after creation's storm. The universe does not rage against its ending. It fades with grace. Some have called this future the dark eternity. But perhaps that is our limitation, not the universe's. To us, darkness implies loss. But to the cosmos, it may be fulfillment, the final equilibrium after eons of motion. All things that began in imbalance must end in stillness. The fire of the Big Bang, the dance of galaxies, the brief flare of life, all were ripples in a larger serenity. When the ripples end, the ocean remains, and maybe that ocean is not silent after all. Perhaps the quantum foam beneath reality still hums with potential, tiny fluctuations birthing and destroying virtual particles even in the coldest void. Each fluctuation is a whisper, a faint reminder that existence can never fully stop. Somewhere, somehow, a new instability might ignite, a new expansion, a new creation. In the language of eternity, even death is temporary. But if nothing ever truly ends, then what is the meaning of this long decay? Maybe it is not tragedy, but transition, the universe exhaling, making space for whatever comes next. The silence beyond the last black hole might be the womb of something new, another Big Bang awaiting its moment. We cannot see it, we cannot prove it, but the symmetry of existence suggests it. The cosmos began in a blaze and may end in one, looping forever in cycles of awakening. Until then, we are the brief awareness of this vast process, the eyes through which the universe sees itself, the voice through which it wonders. We are fragments of its fleeting light, assembled into consciousness for a moment before returning to the dark. Our thoughts are sparks against the long night, but even sparks are part of the fire's story. In the end, the universe will fall silent, but that silence will not be empty. It will be full of everything that ever was, smoothed into oneness, indistinguishable yet complete. The final light of the cosmos will be a whisper from a dying black hole, echoing through space-time like a farewell. Then, the dark will deepen, and the story will pause, not ended, not forgotten, but waiting, as all things do, for the next breath of creation. The universe hides its answers inside its silence. We have asked how many black holes wait beyond the cosmic horizon, how many unseen hearts beat in the dark where light can never reach. But perhaps the question itself is larger than any number could hold. The cosmos has always answered us in reflections, not in totals. It reveals what we can bear to see, then folds the rest behind horizons of time. From the beginning, we've been wanderers tracing the faint edges of knowledge. We counted the stars, then the galaxies, then the black holes within them. We built instruments that could feel the tremor of space-time itself, listening for collisions between objects so distant their echoes take billions of years to arrive. And still, beyond every discovery, there remains an unlit ocean. We can map the observable, but not the infinite. We can measure the visible, but not the hidden. What lies beyond the horizon belongs to no telescope, no formula, only to imagination. Perhaps that is what makes the question eternal. To ask how many is to ask how much of the universe we can claim as known, how much light we can pull back from darkness. But the universe is not a ledger of quantities. It is an unfolding, a pulse, an endless motion between concealment and revelation. Beyond our horizon may wait 10 quintillion black holes, or 10 trillion more. Or perhaps infinity itself lies there, uncountable, unending, expanding beyond every boundary we invent. And yet, the mystery is not frustrating. It is sacred, because in the unseeable, the universe reminds us of our limits, and in doing so, reveals our longing. We are creatures of curiosity, drawn toward the horizon even when we know we cannot cross it. We build our meaning at the edge of the unknowable, in that trembling line where sight gives way to faith. We stare into the blackness, not to conquer it, but to listen. Maybe that's the deeper truth, that we do not study black holes merely to understand them, but to understand ourselves. Their silence mirrors our own questions, what it means to exist, to vanish, to leave something behind. Every event horizon reflects not just light, but thought, the boundary between knowing and being. And when we gaze across the cosmic horizon into the infinite distance, perhaps what we glimpse is not the absence of meaning, but its echo, faint, delayed, distorted by time, but still there, calling back. Imagine, for a moment, the totality of it all. Within our visible sphere alone, there are trillions of galaxies, each a cathedral of stars revolving around a central darkness. Beyond that sphere lies the unreachable, an expanse without end, where light itself cannot catch up to creation. In that unreachable space, galaxies multiply like thoughts, black holes bloom like neurons firing in the brain of eternity. The cosmos is thinking, dreaming, becoming, all at once. Its awareness may not resemble ours, but perhaps it needs us, brief, sentient sparks, to give its dream a voice. The cosmic horizon is not an edge, but a mirror. Every time we look outward, we see both the universe's past and our own reflection. The light that reaches us is ancient, and yet, when it touches our eyes, it becomes new. The observer completes the story. Without us, the stars would still burn, but no one would name them. Black holes would still feed, but no one would wonder why. The act of observation weaves consciousness into the cosmos, awareness blooming within the very phenomenon that will one day reclaim it. Maybe the darkness beyond the horizon isn't empty. Maybe it's waiting for future minds, future forms of perception to continue the search we began. Waiting for another generation of beings, perhaps in another universe entirely, to ask their own impossible questions. The unknown is not a void, but an invitation, and every horizon, whether cosmic or personal, exists to remind us that there is always something beyond what we can see. If black holes are the punctuation marks of creation, then the universe itself is a sentence still being written. Its grammar is gravity. Its language is light. Its silence is meaning. Each time a star collapses, a new story begins elsewhere. Each time we measure a black hole's shadow, we illuminate a corner of the infinite. Knowledge does not end the mystery. It deepens it, folds it inward, lets us see how much we do not know. Perhaps the ultimate answer lies not in counting the unseen, but in understanding why we count at all. To search for what's beyond the horizon is to admit that existence, by its nature, is incomplete. That even in knowing everything within reach, we remain surrounded by the unknowable. That paradox is not despair. It is wonder in its purest form. The infinite is not something to solve, but something to join. A silence we learn to listen to rather than break. Someday, long after we are gone, the universe will return to stillness. The galaxies will fade, the black holes will evaporate, the last photon will drift into endless night. There will be no eyes left to see, no voices left to ask. And yet, in a sense, the question will remain. Written in the curvature of space, encoded in the ashes of radiation, preserved in the memory of physics itself, the universe will remember that, for a moment, it knew itself through us. That consciousness rose from stardust, looked outward, and asked, "What lies beyond?" Perhaps that was the purpose all along. Not to find the edge, but to feel its presence. Not to solve the infinite, but to awaken to it. The horizon may mark the limits of sight, but it also marks the beginning of meaning. Every mystery we chase reveals another. Every answer becomes a deeper question. To fall endlessly into the unknown is not failure. It is participation in the universe's own becoming. And so we return to the beginning. How many black holes wait beyond the cosmic horizon? Maybe countless, maybe none that we could ever touch or name. But in the act of wondering, we bridge the infinite. Our curiosity crosses where light cannot. It is the universe, through us, reaching for its own reflection. A cosmic echo speaking through fragile minds of flesh and time. The fall into the unknown is endless, but it is not empty. It is filled with everything we will never see, everything we have ever been, and everything still waiting to be born. The horizon does not end the story. It ensures it continues. We stare into the void, and it stares back, not with malice or indifference, but with recognition. For in that darkness, we find ourselves. In the end, the question remains unanswered, and that is its perfection. The cosmos hides its meaning within its silence, and we, brief sparks within its immensity, learn to listen. Maybe that's all the universe ever wanted, to be heard, if only once, through us. And somewhere, beyond every horizon, the light still falls, spiraling inward, folding into itself one last time. Not vanishing, but returning home.